Hello everyone and welcome to Module 2 of INST728E, where we'll be talking about Python and Jupyter, and what are Jupyter notebooks, and why is Python our language of choice here. So first off, why Python? Primarily because Python has a great deal of packages that allow for a lot of flexibility in the kinds of analyses we can do. So it has some mature text processing, image processing, video processing, deep learning capabilities as well. For our use, though, we'll focus on the JSON package, matplotlib for plotting, NumPy and pandas for analysis, and then scikit-learn for text processing, and the natural language toolkit, NLTK, for a lot of other text processing tasks as well. These are some standard packages, but from the standpoint of more advanced, more specific analysis, we'll also look at Tweepy, Facebook, and PRAW for connecting to social media platforms, and then TextBlob and GenSim, which will give us some more text analysis capability. We're going to use all of this through the Jupyter Notebook interface. First, though, we can talk a little bit about what a Jupyter Notebook is. So I mentioned in the previous video that Jupyter Notebook is a web-based interactive environment for working with Python or any other language of your choice. And the idea is to bring your code or your analysis and your results together into one place. So anybody can view exactly what you did and what their results are in one single artifact. Now, originally, Jupyter Notebooks used to be called IPython notebooks, but people were so interested or so happy or so excited about this single platform for showing code and analysis results that they came out with the Jupyter Notebook platform, where they divorced the Python language-specific capabilities and the web-based notebook front end. So the current version of Jupyter Notebook is meant to be language agnostic and then support reproducible and replicable research by allowing for all of this code and analysis to be joined with the analysis results. So it doesn't just support Python, it also supports other languages like Scala, Ruby, R, Node.js, or JavaScript, and many other languages that whoever has written kernel for. But for our purposes, we'll be focusing on Python. So what does a Jupyter Notebook look like? We saw this at the end of the last video, where I walked you through a quick introduction or a quick example of Jupyter Notebooks with a bunch of import statements to make sure that our environment was set up correctly. And we didn't go into too much depth now, and here we get to explore this a little bit more. So a Jupyter Notebook is generally divided up into cells. Some cells contain code and results, and we can bring these together and have this one package or this one interface or this one file that people can share and see how a particular set of analysis produces some specific set of results. And then you can take this analysis or these analytical results and export them as another notebook or a straight Python script, or as a web page in HTML, or even a PDF that then you can email or send around and share your results with the broader community. So what is a Jupyter Notebook? As I mentioned, it's based on cells, and we have two main kinds of cells. We have markup cells here, where we can have text or HTML, so we can embed images or YouTube videos into our notebooks. And then we have code cells. The code cells are where you put in our case, our Python code that does some of the analysis or some analytics. We'll read in a file, do some processing, maybe print out a visualization as well. So a markup cell generally looks like this. It's one standalone cell. It's formatted using Markdown, which is a popular simple Markdown format. You can look at, or you can Google for simple Markdown tutorials or Markdown syntax that will give you some insight into what Markdown looks like. But generally, it's just a text box where you can put in text with some additional decorators for formatting.
So if you double click on a markdown cell, you'll get an interface that looks like this, where you can put in some text. And then when you press run, up here at the top, as we talked about before, then you end up with a formatted version of your markdown cell. Now, like here. And now we have a code cell that has syntax highlighted code in whatever language your kernel is running in. So in this picture, we have a Python 2 code cell. In our notebooks, we'll use Python 3. And then we have our code cell, and if you run that cell, you can have output as well. So when we saw code cells being run at the end of the last video, we didn't really have any output, but here you can have some visualization. So we have this nice plot, or we can have we can show images or other kinds of plots or videos or animations. Anything can be, or you can have lots of text. Anything can be in these code output cells. So here's a nice example where somebody put together a visualization of Texas unemployment by county in 2009. Jupyter Notebook has a lot of fun capabilities since it integrates well with Python. So the Python graphics library is called graphing library is called matplotlib. It's a very extensive library. So there's a popular online webcomic called XKCD. It's done by a guy named Randall Munroe. And it's one of its defining characteristics are these fun graphs. Well, it turns out matplotlib has a library called XKCDify that will take some graph and then produce a version of it that looks kind of like Randall Munroe's style. And there's a whole other gallery of Jupyter Notebooks, because Jupyter Notebooks have kind of revolutionized the data science field by bringing your analytics and results together. And GitHub.com has a nice engine for rendering notebooks directly in your browser, so you don't even have to have the Jupyter Notebook engine in order to view some of these notebooks. But yeah, if you go to GitHub.com and this URL, you can see a list of many different kinds of Jupyter Notebooks where people have done all kinds of interesting analysis in different languages. So I'll go through the Module 2 notebook, which will give you some examples about using Jupyter and the Python packages that I mentioned before, so JSON and RE and NLTK and such. And then you'll do some homework based on those packages. So this Module 2 homework, you can look at the Module 2 homework IPython notebook file in Elms under assignments, and the associated world news on Reddit from 2008 to today.zip file. So that contains a number of posts to Reddit and the world news subreddit. And then we'll use that to do some very simple analysis on headlines using some of the packages that I've mentioned. So get our feet wet in this crisis informatics data analytics space. So once you have these two files, you'll use this notebook to analyze the world news community headline to find some things like generally common keywords, and then I'll ask you to select a particular kind of disaster of your choice, like earthquake or terrorist attack or shooting or bombing, and find other keywords that are used within headlines that mention your specific kind of terror attack. As in the previous video, I ended with some additional resources, and I mentioned there is a nice intro to Jupyter Notebook on YouTube that you can go check out. So this would be a good time to do that. That'll give you some more input on how to interact with the Jupyter Notebook platform. So coding cells or running cells, getting help from the Jupyter Notebook help mechanism. Jupyter Notebook also has some nice tab complete features that you may find useful. So I recommend this video as some additional reading if you like. Okay, now we'll switch over to the Jupyter Notebook example that we have for Module 2. So we'll come back to this list of notebooks. You can go find this on Elms as well. And what we'll do in Module 2 is explore some of these standard Python packages that I've talked about. So we'll look at regular expressions, plotting with matplotlib, using pandas for some simple data analysis, reading in some JSON. So I'll show you just a brief intro about JSON before we talk about that in the next modules, and look at the scikit-learn and LTK. So I've developed or divided all of these into little sections for you to see and play around with. I have an example of an embedded YouTube video using NumPy for calculations and such, so feel free to follow along or run this yourself. And then after that, we'll talk about some more sophisticated packages that we'll use here, like TextBloblib, basemap, and show some mapping capabilities. So let's start here at the top. So this is a markup cell, like I've mentioned before. It's done in Markdown. So if you press Shift-Enter, it'll run this and format it for you. Same thing here. So, all right, now what we'll do is use the regular expressions package. If you've never heard of regular expressions before, don't worry too much about it. This will be helpful if you want to use them in future homeworks. But the idea is a regular expression allows you to construct a pattern of text that will match strings in a more flexible way than you might be used to. So they're typically used for formatting validation. So for instance, if you want to ask somebody to provide you an email, or you want to look for email addresses or web addresses or something in a web form or in a bit of text, then we know what an email address looks like, and it has some particular requirements. So here, if we look at this email address list, we have a couple of valid email addresses. These are actually my email addresses, cbutton@cs and cbutton@umd. And then we have a couple of invalid email addresses. And what we want to be able to do is filter out valid and invalid, or filter out invalid email addresses. So with regular expressions, we can do this by creating a pattern of a valid email address. So here, this is what we do here. What we take is this, we use the regular expression package that we imported right here, and then we compile our pattern. So this is a semi-advanced regular expression. Essentially what this block says right here is for a capital A, B, C, D, etc., a lowercase a through Z, and the digit 0 through 9. This plus, we can match any one of those characters, and this plus means we have to match at least one of those characters. So this says our valid email address has to start with some alphanumeric character. Then we have this parenthetical expression here that says, well, anything that's in this parentheses, we have this plus sign again, so we have to have at least one of these. And inside this parentheses, we have this slash period. This slash is an escape because period is a special case or a special character of regular expressions. That means match anything. We want to match explicitly a dot. So maybe you have an email address that has a dot in it. Gmail addresses often have dots in them. This question mark means match one or none of these characters. So we can have a dot or we don't have to have a dot. And then we go back to this same A through Z in capital and lowercase and 0 through 9 digit thing. So now we're saying we can have another string of at least one alphanumeric characters that may include a period. Now the difference between this block and this parenthetical block just means that we cannot start an email address with a period, but a period may exist prior to the @ symbol of an email address, which we have here. And then we do the same thing that we've seen before. We have another alphanumeric set that we can have at least one of those, but potentially any number, and then a dot for our domain name. We can have that one or more times. And then we have to end with at least one letter. So we can't end on a dot. So this is a big pattern that we've compiled up that should match these two email addresses, or these two addresses, and not match these two addresses. So now we can run that. So this pattern gives us a compiled regular expression. And then for every address in our email address, we can go through and check to see, does that email address match the pattern that we created? And if it does, then we print out valid. And if it doesn't, we print out invalid. And then we get what we expected here as output. So regular expressions are something that's a nice thing to have when you're doing filtering. So maybe you want to capture references to Paris that are upper and lowercase, or references to Parisian and Paris. So you may use regular expressions for that. So this is a useful tool that is nice to have in our arsenal. For real data analysis, though, we'll flip over to Matplotlib, NumPy, and Pandas. So we can see we've dropped into the formatting or markdown cell there. Now, an important thing to do in Jupyter when you're using Matplotlib is this magic line here that's percent matplotlib inline. What this ensures is that when you call Matplotlib to create a graph, that it gets printed or outputted beneath the cell that you created it in, rather than as a different window, which is what would generally happen if you were using a regular Python script. So go ahead and run that. You won't see any output, but it's an important thing to include. So don't forget that. If you run into a problem where your visualizations are being presented outside of the Jupyter Notebook browser, then it's probably because of this matplotlib inline thing that hasn't been executed. Okay, so while the regular expression thing was a little bit maybe complicated, here we'll just do some simple computation. The two things that we need, because we want to make a very simple graph, is Matplotlib, which is the general graphing library, and then PyPlot, which is an object-oriented interface to the Matplotlib library. We'll go ahead and say import matplotlib.pyplot. That gives us this sub-package within Matplotlib. And then we'll alias it. We'll use this as keyword, as PLT, that says, well, anytime we use the variable name PLT, we're referring to this matplotlib pyplot package. All right, now we'll do some very simple math. So we will use Python's range function to create a list going from 0 to 7. And then we'll create 3 different y values that use this x value. So these are called list comprehensions. This says return an x for every x in our list of x values. This says return 2 times x for every x in our x values. And this says return x to the 0.5 power, or give us the square root of x for every x in our list of x values. Then we can use the matplotlib pyplot package, this PLT package, to plot these values. So we do plt.plot. We can do x and y with some label, x and y2, x and y3, and we can describe these curves by their label, which will get printed in our visualization by calling plt.legend. And then we can set some axis labels to give us some insight into what we're actually plotting. I encourage you to make sure you always have axis labels whenever you do any sort of plot to make it more legible. And then finally, we call plt.show, which says, well, whatever visualization or graphic that you created, go ahead and print it out now. So I'll hit Shift-Enter and run this cell. And we see this nice visualization here where we have 0 to 7 in our x domain, and then our range from 0 to 14 for 0 times 2 and square root of 0 and just 0 onto the different values for f of x. So this is a very simple visualization. We can now move on to some more interesting ones. So we'll use Python's random number generator, where before we used a straight x and y value with a known set of values for x and then a function of x. Here we'll use the random number generator to give us a bunch of random numbers. So we'll say we'll look at 8 values. So x values, or x vals was our 0 through 7 before, so its length is going to be 8. And this range will give us a 0 to 7. and our R values will get 7 random values in the range of 0 to 1. And then we'll call scatter plot on these random values using the 0 to 7 X values that we have and the Y values that we have here. Some more labeling for our figure, and then we'll show it. So you can see these different dots for the different random values we got from 0 to 1. And if we run it a couple of times, we'll get different results because we're using a random number generator. Okay, so that's we've now seen a regular line plot, which we saw here. We've seen a scatter plot, which gives us all these dots that are not connected. But we could connect them, so we can change this plot or this scatter to a plot, and now we have these dots. But the scatter makes more sense for that particular visualization. And now we can look at histograms as well. So we'll do the same thing that we did before, but instead of using only eight values, we'll use 1,000 and generate 1,000 random numbers from 0 to 1. This gives us this list here of these 1,000 random values, and then we can call plt.hist. Note we don't have any x value here because it's going to take this set of 1,000 random numbers and bin it up into a set of 10 bins and tell us how frequent each of those bins are. So we have the X label and Y label that we've had before, some grid lines to make our graph more legible, and then we'll go ahead and show it. And this is essentially what we expected. The random number generator should be uniformly random. So we have about the same number of random values in each bin, from 0 to 0.2, 0 to 0.2 to 0.4, and so on. And again, if you run it a couple of times, then you'll get some different results, but it should be close to the same, this nice uniform distribution here. It's like this one's relatively nice. All right, Matplotlib has a whole bunch of other capabilities that you can play around with, some other types of visualizations, both in 2D and 3D. And there's a bunch of gallery examples that you can look at by checking out the gallery.index, or the gallery index here. And there's a nice YouTube video on Matplotlib as well that I've linked to here. To show you how to embed one of these YouTube videos in your Jupyter notebook, you can do this as well by calling or by importing the IPython display package and importing the HTML function within there, and we can call that and give it some HTML that'll get rendered directly into our notebook. So if you want to do this, if you want to embed a YouTube video or an image or something via HTML into your notebook to add some additional visualization or cite some website or some blog or something, you can do that relatively easily. All right, so that's our overview for Matplotlib. The next thing we'll talk about is NumPy. So NumPy is something that we won't use very much of directly, but a lot of the packages that we will use rely heavily on NumPy. So it's primarily a package for numeric computation. So we will import it. Often by convention, when people import NumPy, they generally say they alias it to NP. And then we can call all the capabilities of NumPy through this NP variable. Now, the difference between NumPy and some of the stuff that we've seen, or some of the stuff you may be familiar with in terms of lists, is NumPy makes manipulating lists of numbers relatively easy. So let's say here we have a list in Python that goes 1 to 7. We can print this list out. It'll give us a nice pretty print for us. But if we wanted to add 5 to each one of the values in this list, then we'd have to do either a for loop or some list comprehension like this that says for every x in our list, we will add 5 to it. Ideally, what we want to be able to do is say, well, here's our list. We want to call the plus symbol and I want to say plus 5 and have this be add 5 to every single element in this list. This is more concise, makes sense on what's going on, but Python doesn't actually support this kind of capability, directly at least. So what we want is this, we've printed out this list, we've printed out this list comprehension that adds 5 to each one, that's here, but if we try and add 5 to the list directly, then we error out. With NumPy, we can take some numeric list from Python, create a NumPy array from it. We can print that array out. We'll see that it has the same kind of information, but now we can do this direct +5 addition. And NumPy will default to element-wise addition for us. So if we print this out, then we see pretty much exactly what we saw before for this ARR1. It's the same list that we saw. And now this ARR1 + 5 gives us 6, 7, 8, 9, 10, 11, 12, which is the same values that we had here when we were actually able to add 5 to everything. So that's useful. And NumPy exists all throughout the majority of any sort of sophisticated Python analysis and is generally natively supported or directly supported by a large number of packages. So we can use this directly with matplotlib and say, well, we'll plot out this range 7 and the array values we had, and we can do 2 times the whole array. So we don't have to do any list comprehension here. We can print this out and we see what we expected. All right, so that's NumPy in a nutshell. Now we can look at pandas, which we'll use and you'll want to use in your homework, or I'm having you use in your homework. So pandas, same kind of thing that we did with NumPy. We import it, we alias it as PD because we'll use it a bunch. And then, as an example, we will use this file from Just Markham repository in GitHub that has a tab-separated value of Chipotle data, of different orders from Chipotle. Without pandas, the way to read this file would be to call Python's open function, read every line, parse every line. But pandas gives us this read CSV function, which makes this kind of thing much easier, where we just call pd.readcsv. We give it the file name that we want. It supports files on your local computer, URLs, and a couple other formats. And we say the separator will be this tab, since we're using a tab-separated file. And then we can print out this data frame. So this df here at the end gives us a nice pretty printed format where we get a unique order ID, a quantity number, the name of the thing that was ordered, a description of the thing that was ordered, and an item price. And we have this for a bunch of different orders. So we have about, I guess, 1,834 orders over 4,600 rows, and the different columns that we just described that we saw. So now that we've loaded this into Pandas' data frame, we can do some analysis on the data frame directly. So we can look and see how big the data set is using this df.shape function, or attribute rather, which tells us that we have 4,600 rows by 5 columns. We can take the item price column from this data frame and apply some function to it that will convert the price, this $10.98 for $10.98. We'll strip off the dollar sign by doing x.replace $ with an empty string, and we'll convert that to a float. So that's a number that we can add up. And then we can use this to calculate the mean price for all the items in this list. So we get, on average, the item ordered is $7.46. We can do some more interesting things with capabilities of data frames by converting a particular column into a string and then calling the contains function within this string method and say, does this string contain chicken? If so, then we'll say we have some sublist of these Chipotle orders that only contain chicken, and then we can say, well, how many contain, or how many do and do not contain chicken? So now, of the 4,000 or 4,600 rows of items that people ordered, looks like 3,000 of them are non-chicken elements. So then you could rerun this analysis for what is the mean price of chicken-based and non-chicken-based orders. And we can do the same kind of thing with histograms and data frames that we did with Matplotlib. In fact, pandas and data frames work on top of Matplotlib and can provide visualizations for us. So we can say, as we did before when we removed the $ from our prices and converted them to floats, well, once we have that data, rather than calling the mean function that we did above, we can call the histogram function and get a histogram for the average or for the different costs of items on Yes, the NLTK stands for the Natural Language Toolkit, and it has support built in for tokenization, which means taking a string of words or a string of text and breaking them into separate words. It has support for stop words and frequency distributions and all these other things as well. In this example, we'll look at stop words for tokenizing data. So the first thing we'll do is we'll import NLTK. That's what we'll do here. And then from the NLTK corpus, which is a bunch of different data sets that NLTK provides, you can check out NLTK's documentation for the different corpora there. We'll import the stop words list, and then from the tokenize library, or the tokenize package of NLTK, we'll import the word tokenize function, which will let us provide a set of, or a string of text, and tokenize it up or split it up into different words. Now we can take the Chipotle data set that we had, this data frame, and take this choice description column, which occasionally had no value. So here we have this first row in our data set. We have chips and fresh tomato salsa as the item name, but it has no description. So we get this NaN, which stands for not a number. We can use pandas to say we'll drop all elements of the choice description column that have no value, and then we'll convert this to a list. So this choices list now gives us all the non-empty descriptions of choices from our Chipotle data set. Now for the first 20 choices, I'll show you an example where we tokenize these strings. So we'll go ahead and run this, and we'll see Clementine with these square brackets around it. After we apply the word tokenize function to it, we get an output square bracket, the word Clementine, and a closing square bracket. And the same thing with apple. Then we have tomato or tomatillo red chili salsa hot, and black beans, rice, cheese, and sour cream. That also gets tokenized into an open square brace, tomatillo red, and then an element for chile, list element for salsa, list element for hot, and so on. So we can look back up at the values here. So the chicken bowl was tomatillo red hot, or tomatillo red chili salsa hot, black beans, etc. We were able to tokenize that up into a bunch of different words. And this will be hugely useful when we look at tweets, because with these tweets, we'll want to break tweets up into individual words so we can look at the most common words. So these are all the examples of the different tokenizations we did. Now from there, we can say, well, what is the most common set of words in this set of choice descriptions from Chipotle? So to do that, we'll build a map from a Python dictionary. And for every choice in our list of choices, what we want to do is tokenize that choice string into a bunch of words, which gives us all this output that we just saw. For every word, we'll go ahead and convert it to lowercase, just to avoid any sort of case discrepancy. And then for every word in this lowercase list of words, we will go to this dictionary of tokens that we have. We will check to see if this token exists in our dictionary. If not, we return 0, and if we do, we return whatever value is there. And then we add 1 to it. So this lets us count up every time we see each token in this list of descriptions. And then we can go through and print out this map and see what the most common choices or choice descriptions are. And this sorted function here lets us sort our map based on the counts of each token. So we will sort all the items in our dictionary. We'll use this key attribute to provide a lambda function that will return the value or the count of that particular token. And then we'll go ahead and reverse it so we can look at the first few. What this will tell us is the first element we print out will give us the most common token. So you can go ahead and call this. And we get the most common tokens are commas and open and close square brackets, so those are used hugely often. And then we see salsa, rice, cheese, beans, and lettuce are the top 5 most commonly used choice descriptors in this Chipotle dataset, which I guess to me makes sense because I generally have salsa, rice, cheese, beans, and lettuce in my Chipotle bowls. Okay, so what we just saw was how to go through and count up the most frequent keywords in a set of text. Well, we did this manually using Python, but we can also use NLTK to do this for us. So let's look at a more sophisticated data set from the NLTK corpus. So we'll look at the State of the Union data set, which gives us every presidential State of the Union from 1945 onward in text form. We can print out the first, or rather the last 1,000 characters of it. So I guess it's 1945 to 2006. So this will be one of George H.W. Bush's State of the Union in 2006, or I guess his 2006 State of the Union. And we see we have all this textual content. Now what we want to do is use the word tokenized function that we saw before on all of the State of the Union address content. This will give us a bunch of different words. And then rather than doing the dictionary and iterating through the list and adding to the dictionary and incrementing values, we can use NLTK's frequency distribution function, or frequency distribution class. So this NLTK.freqdist, you give it a list of text or a list of iterable objects, and then it'll build a frequency distribution for you that will get stored in this variable named here. So now we can call most common on State of the Union freak and say, well, give us the 20 top most common words and what their counts were. So this may take a second because it's going to read through all this text. And we see the most common word was, as expected, the most common word in the English language, the, followed by some punctuation, period, comma, of, and, to, in, we, things that aren't very useful to us, but things that are unsurprisingly common words. So now what we want to do is see if we can filter out these highly common words and get at some more interesting frequent content. So to do that, we will import the string package, which is built into Python. And this lets us look at punctuation. And then we will look in the stop words in the English language corpus, so the stop words.words in English. And in the string.punctuation attribute, which is all the different punctuation symbols in that can be in a regular string. So your commas, question marks, periods, colons, etc. And then for every element in this list of stop words and punctuation, so this is what this for loop will do, if this element exists in our frequency distribution, we can go ahead and remove it. So this del will delete from the State of the Union frequency distribution that particular stop word, and then we can rerun this most common function, and then we get a different list, right? So now we see must, apostrophe s, a double dash, and then must, people, world, new, Congress, America, government, American, nation, peace, federal. So these are the top 20 most frequent keywords that are not stop words that are used in presidential State of the Unions. And then rather than having to do this or figure out these counts manually, we can rely on NLTK's freqdist to do it for us. And then we can use that to combine NLTK and matplotlib to get a histogram of the different keywords. appear 12,000 times. There are about 12,000 words that appear between 0 and 100 times. And then more than that, so tokens that appear 100 to 200 times, there are far fewer of those. Tokens that appear 150 to 250 times are even fewer, or much fewer, and tokens from 225 to 325 are even fewer. So most words appear relatively rarely, and you have a few words that appear more frequently. Okay, and you can make other sort of visualizations here as well. All right, the last two things we'll look at are some more advanced packages, so specifically TextBlob. First, TextBlob is a more accessible version of NLTK. It's actually built on top of NLTK, and it gives you a lot of easy access to capabilities within NLTK. So for instance, we can get sentiment analysis, detect language, this kind of thing. So the first thing we need to do is from the TextBlob package, we need to import the TextBlob class. And then what we want to do is look at all the different sentences of the State of the Union data that we have. The NLTK corpus is nice in that it can give us all the sentences as well as all the raw text. And we'll take just the first two sentences and join them by a space so we can have TextBlob actually identify the sentence for us. And we can go ahead and print this out. So we get this first sentence: Mr. Speaker, Mr. President, members of Congress, it is with a heavy heart that I stand before you, my friends and colleagues in the Congress of the United States. So this is the third sentence in our list of State of the Union sentences, and we are applying TextBlob to that. So now we can use TextBlob to get a bunch of information out. So we can use it to detect language, which we would expect to be English. We can use it to detect its sentiment, which is this polarity. And we can use it to extract noun phrases and print those out. So we see TextBlob says we think it's in English. The polarity of this sentence is -2, so it's more negative than it is positive. And then we can look at different nouns in this data, or nouns in this sentence, and we get Mr., Congress, and heavy hearts. So this is just an example of what you can do with TextBlob. So now we can use TextBlob in all of the sentences from the State of the Union address data set and come up with an average sentiment score. So here we have TextBlob. So for every sentence in our list of sentences, we will join it with a space. This will take our tokenized sentences, or tokenized sentences, and add spaces between them, which is what TextBlob expects, and create a TextBlob object for each one, and then we'll extract the polarity from that sentence, and then turn that into a NumPy array. So this is what we get for per sentence fields. What is the sentence, or what is the sentence level sentiment in every sentence of the State of the Union address? And then we can calculate the average sentiment by just calling .mean, and get a histogram of the different sentiments, and then plot them out. All right, so we see the average sentiment per sentence for the State of the Union address is positive, so this 0.1054 out of -1 to +1. And when we look at the histogram for this sentiment task, we see that most sentences, the vast majority of sentences, are between 0 and 0.2 in sentiment, with about 10,000 of those sentences. But we have a few sentences on either side. A few sentences that are more negative, maybe a couple of sentences that are hyper-negative between -0.75 and -1, and a few more sentences that are hyper-positive as well. Okay, the last thing that we'll look at is basemap. Give you some insight here. So basemap is a package for plotting maps of the world. You import it using this mpl toolkit.basemap package. So this is a matplotlib toolkit, and the basemap function, or the basemap class within this toolkit. We do the same thing that we would have done, or we do generally, with pyplot, which is create a figure and get its axis, so you don't have to worry too much about what's going on here, but this lets us add stuff to the axis, which is what basemap's going to need. And then we can use the basemap class and say, we want to look at a particular part of the planet. So it works on bounding boxes based on lower left and top and upper right corners. So we'll say the lower left corner in longitude and latitude are negative 160 by negative 40, and the upper right corner by longitude and latitude are 120 and 60 degrees. So 120 degrees east and 60 degrees north. And set the resolution and projections. This is a Jupyter projection. You can look that up to see what exactly that means. And here's where we will center the visualization. And then we'll look at the latitude and longitude for the city of New York and the latitude and longitude for the city of London. And what we want to do is create an arc between these two cities, which will be the great circle between them. So this would be the path that flights would fly from New York JFK or LaGuardia to London O'Hare. So we can use the base map class to do this for us. First, now that we've created this base map object, we can say, draw this great circle from New York to London with a particular line width and color. And then we also want to fill in the continents, draw coastlines so we can see where these different countries are, or where these different cities are. Draw parallels, so this will draw the lines of latitude, draw meridians, which will draw the lines of longitude, and then we can set the title of our graphic and show it. And here we go. We have this nice visualization of the planet with this great arc between New York City and London. So I encourage you to experiment with this as well, so you can look at great arcs between other countries. One would expect if you were to try to draw a great arc between, say, Quito, the capital of Ecuador, and Kenya, or Nairobi, the capital of Kenya, or a city in Uganda, you might see a great arc that would be a flat line along the equator. All right, well, that's a quick overview of all the different packages that we'll use in this class, so I encourage you to play around with them and then check out homework 2. So I'll show you briefly what homework 2 looks like. So you have this homework 2 notebook with asks you for your name and email. So if you double-click on the markdown cell, you can put in your name, and then look at the directions which says to use the pandas that read CSV file to read in the Reddit World News headlines and find common words used in these headlines. So you want to download that World News zip file and unzip it, and then call or import pandas and use read CSV on wherever you set that file. This DF shape will just tell you how many elements are in that file. So this should be, task 1 should be relatively easy. So task 2 now asks you to use NLTK's word tokenize function to tokenize all the titles in this titles of the column of this CSV file, and then print out what these most common tokens are. Then for task 3, what I want you to do is filter out all column or all titles that do not mention a particular kind of disaster. So choose choose some disaster type like hurricane, earthquake, terror attack, flood, tsunami, etc., and use Python to figure out titles that include these keywords, and rerun your task 2 code to find the most common tokens associated with that particular type of disaster. All right, so if you have any questions, feel free to post on Slack, and good luck.